The Bayes theorem. We search for a movie, we find a movie, and now we want to know whether we would like it or not. So we go to IMDb or Rotten Tomatoes or Metacritic, whatever your choice. Let's take IMDb, and we check the grade of this movie, and we find that its grade is 8.2. Now we ask ourselves, what is the probability that we would like this movie? Let's formalize this. Step 1, let's formalize the question. We say that the question is, in general, what is the probability that we would like a movie given that its IMDb grade is larger than 8.0? It's a threshold. Step 2, we don't know the answer for that. We have no idea. What is the probability that we would like a movie given that its grade is larger than 8.0? So step 3, we go to IMDb and we now try to base things out of data. We search our history for 10 movies from the past that we watched, and we write on the side whether we liked each movie or not. And we know, because these are 10 movies that we watched, and we know whether we liked it or not. Then we go to IMDb and write a score for each of these movies. Now, the amazing, shocking thing about the Bayes theorem is that we can reverse it. We can come from one question into one solution and from the other question to the other solution. For example, if we ask, what is the probability that we would like a movie given that its IMDb rating is larger than 8.0, we can answer this question with an estimation by asking the reverse question. What is the probability that a movie's score would be larger than 8.0 given that we liked it? And this question, we can basically try to answer from our sample data. Because from our sample data, we've sampled 10 movies, and we're going to check for each of them the grade. Why couldn't we just sample the reverse side? I mean, we could take 10 movies that had a score larger than 8.0 and ask for each of them whether we watched it or not, whether we liked it or not, but there are tons of movies. So which movies would we choose? So it makes less sense to ask this question. Okay, because we can't just take 10 movies with grade larger than 8.0 and ask whether we liked it or not, because it's possible that we didn't watch any of them. So we do the reverse, which is what Bayes' theorem gives us. The ability to ask the reverse question and then to answer the first one. Okay, so we took these 10 movies. For each of them, we wrote whether we liked it or not. For each of them, we note also the score, whether it's larger than 8.0 or not. And now we do the reverse calculation. The reverse calculation would be what is the probability that the movie has a score larger than 0, given that we liked this movie. So we see that we liked actually, let's say, 9 movies, but only 7 out of them had a grade larger than 0. So this would be the probability of score is larger than 8.0, given that we like them, times the probability that we like the movie, divided by the probability that the score is larger than 8. And we must repeat this because this is very unclear. So basically, when we ask the reverse question, it's P of A given B is equal to P of B given A times P of B divided by P of A. Basically, what we do is we ask then the reverse question, P of B given A, which is what is the probability that the movie would have score larger than 8, given that we liked it, and we know by the data. We multiply it by the probability that we, in general, like the movie. Because let's look at it like this. If we like 100% of the movie, this would increase the probability that if the score is larger than 0, that we like it, because we, in general, like many movies. And when we divide it by P of A, which is the probability that the movie would have a score larger than 8. Why do we divide it by the probability that a movie would have a score larger than 8? Let's take an extreme example. If all movies having a score larger than 8, this would give us 0 knowledge. So we would divide by 1 and nothing would change in the probability. If only 2% of the movies have a score larger than 8, then this would give us a lot of information. So we would divide by 0.02, which would increase our total probability. So the probability of A given B is the probability of B given A times the probability of B divided by the probability of A. Or in other words, the probability that the score, the probability that we would like a movie given that its score is larger than 8 is the probability that we like the movie, is the probability that the score of a movie is larger than 8 given that we liked it, times the probability that we like, because the more we like, the higher the score, divided by the probability that the score of the movie is larger than 8, because the less movies that are like this, the more information that we gain.